Hello everyone, good morning. Hello, am I audible?
Yes, sir, you are
Yes.
audible.
Okay, so we'll wait for a couple of minutes and we will start. Okay. Okay, so good morning everyone. So yeah, so today is a revision session for the quiz 2. So at first, we'll take your doubt from mock 2, and then after that, if you have any doubt in the previous week, you can ask that, and after that, we'll go for the revision slides. Okay. So yeah, I hope you all have attended the mock 2 test. So any doubt in that? Any question? Hello, I'm audible, right?
Yes, sir.
Yes, sir.
Mhm. Any doubt? Mock questions?
Fifth,
Yes.
Sir, in question 16, part 2, how we solve for MVD? I am not getting it.
Okay, we'll take that question. Yeah. Question number 16, part 2. Just 1 minute. Okay, so is my screen is visible? That question?
No, sir, not yet. Yeah, it's
Hello?
visible now. Yes, sir, it's visible now.
Okay, fine. Yeah. Okay, so yes, anyone? Can you tell me the approach for solving this question? Have you tried this? So we have 5 attribute A, B, C, D, and we have given 2 tuples, right? 0, 1, 2, 3, 4, then 0, 5, 6, 7, 8. Okay. Now let us check for the first condition. Let us check for the A multi-determine B. Okay. So yeah. Yes, anyone can tell me? Any one of you have solved this question? How to proceed further?
Sir, may I?
Yes, yes.
Sir, based on the definition we have, if alpha multi-determines beta,
Hmm.
then there exist transactions T1 and T2 such that if
Not transaction, tuple.
tuple, sorry,
Yeah.
T1 alpha equals T2 alpha, then T3
Huh.
alpha will be equal to T4 of alpha,
Okay. Okay.
and T1 of beta will be equal to T3 of beta, and
T3
T4 of beta will be equal to T2 of beta.
yes.
And we have T1 of R minus beta will be equal to T4 of R minus beta,
Hmm.
and T2 of R minus beta will be equal to T3 of R minus beta.
Yeah. So please remember this condition, okay? Yeah. So T R minus beta. Now here alpha is A and beta is B, right? So here if alpha T1 equals to alpha T2, so this is T1 T2, then we can check for this condition. And there exists T3 and T4 such that like alpha T1 equals to, right? So it is 0, 0. Yes, so here T1 beta equals to T3 beta, right? So our beta is, sorry, T1 beta is 1, so T3 beta will be 1, and same for T4 and T2, that is 5. Now here T1 R minus beta equals to T4 R minus beta. Now what is R minus beta here? Is anyone?
C, D, and E.
C, D, E, right? A also.
Yes, sir.
Yeah. So it should be like T1 tuple 4 should be equals to T1, right? So T1 that is 2, 3, 4 equals to 2, 3, 4, and here 6, 7, 8. Right. So this this 4 tuple will satisfy this condition. Okay. Now how to check whether this approach is correct or not? Say A multi determine B. What it means, like if we keep the A same and interchange the beta value, then we'll get the same resultant table. So say suppose I am where is B? Yeah, I am changing this B, right? So instead of 1 it is 5, and instead of 5 it is 1. Now is there are you getting the same table as of previous? So 0, 5, 2, 3, 4, right? And here you can see 0, 5, 2, 3, 4 was there. Right. So here is 0, 1, 6, 7, 8. Here also 0, 1, 6, 7, 8. Right. So this is the one of the way to check the MVD. Now this condition is satisfied, right? A multi determine B. Then how to apply second? How to check for the second MVD? Yes, anyone? Yes, Vishakha. You have doubt in this part only, right?
Yes, sir. I have the doubt in the same B multifunction D.
So can you tell me your approach? How did you approach this particular thing? The conditions you know, right? So
Yes,
here, yeah.
sir.
So,
Same condition would apply na, like A multi determine D.
yeah, same condition, same core condition. So here alpha is our B and beta is D. Now if you consider this as T1 and this one as T2, like for 1, 1, or another case is that you can consider this one as T1 and this one as T2, right? Because alpha T1 equals to alpha T2 must be same. Now here there will be two possibilities, right? So I will erase this condition. I hope you remember this one.
Sir,
Yes.
we cannot consider, matlab, you are telling that you are considering T3 and T4 here as T1 and T2 for calculating B multi-dependent to D, but we can also take T1 and T2 as the base and then also calculate, right?
see, we are checking for B multi-determinant D, right? So we can apply those four conditions only if that T1 alpha equals to T2 alpha, right? The two, like for alpha, there must be a two tuple. So here there are two possibilities. If we consider this as alpha and this one as alpha 2, right? And in another case, we can consider take as 5. So what I will do, I will consider first B equals to 1. That is T1, T2. That is A, B, C, D, E. In another case, A, B, C, D, E. And here my T1, T2 will be 0, 5, 6, 7, 8. So basically, I will split this table in two subtables, right? 2, 5.
Yes, sir.
2,
In
3,
one you are taking T1 and T3, and one you are taking
Yeah.
T2 and T4. Okay.
2, 3, 4. Here 0, 1, 6, 7, 8. Now apply those condition here. That is T3, T4. Sorry. So here alpha must be same, right? Alpha is B. So that is 1, 1. Now T1 beta equals to T3 beta, right? So T1 beta is D equals to T3 beta, that is 3. And T2 beta equals to T4 beta, that is 7. And now T1 R minus beta equals to T3 R minus beta, right? So T4 R minus beta, T4 R minus beta equals to T4 R minus beta. So here R minus beta means A, C, and E, right? So here T1 is 0, 2, 3, 4. So T4 will be 0, not B, yeah, 2 and 4. And here T3 R minus beta equals to T2 R minus beta. So 0, 6, and 8. Okay. Any doubt in this part, like how I got this, right? Is it clear, right?
Yes, sir. Clear.
Yeah. Now same thing we can apply to this table also. Like beta is 5 here. Here now T1 R minus, T1 beta equals to T3 beta. T1 equals to T3 beta, that is 7 and 3 in this case. And T1 R minus beta, so that is 0, 6, 8, and 0, 2, 4. Now we will get 8 tuples here, okay, because we have split this table in two subtables, right? So total there will be 8 tuples, this 4 and this 4. Now check the option. So 0, 1, 2, 7 is there? No. 0, 5, 6, 3, 8 is there? 0, 5, 6, 3, 8 is there? Yes. Yes, this one. 0, 1, 6, 7, 8 is there? 0, 1, 6, 7, 8. Yes, this is T2. This is there. 0, 1, 6, 3, 4 is there? No. Right? So correct option is second and third. Okay. So you will get 8 tuples here. This is a simple approach. There is another approach also, but better to stick to this approach.
Sir, we actually solved this, but with a different approach. But I don't know if it is correct. Can I share the share?
Yes, yes, yes.
So since you're saying A is multivalued and to B and B is multivalued to D, which means that for same A there can exist multiple Bs. The possible values for B are 1 and 5. So the possible values of A should be 0, 1 and 0, 5. So those, and for B to D you have a multivalued relationship. So for B it takes values 1 and 5, and for D you take values 3 and 7. So it can be 1, 5, 1, 7, 1, 1, 3, 1, 7, 5, 3, 5, 7. So these are the combinations that I have to look for. But for C and E, the values cannot change. It can only be the combination of 2, 4 and 6, 8. So other combinations are eliminated. Will this logic work everywhere? I just wrote down the values of A and then mapped it to multiple Bs, as in for 0 to 5.
So you are going to the option, right?
No, I'm just making a table from A to B.
Okay.
whatever possible combinations are there. So A to B, you can have 0, 1 and 0, 5.
5, yes.
And then from B to D, you can have 1, 3, 1, 5, 1, 3, 1, 7,
7,
5, 3, 5, 7.
5, 3,
5,
5,
7.
7.
Rest of the values are fixed. They cannot change. It should only be 2 and 4, 6 and 8. Because that's not multi-valued. It should only be 2, 4, 6, 8. You cannot have any other values. Because they're not multi-valued. 2 can only give you 4, right? For E. There is no multi-valued relationship between C and D.
1, 3, then 5, 3 here, then 1, 7,
5, 7.
5, 7, right? Okay.
Yeah. So 0 will be the value of A in all cases because A does not have any other value. C and D can only be 2, 4, 6, 8. So combinations of 2, 4, 6, 8, 2, 4, 6.
And here also 6, 8, 2, 4.
2, 4.
So we're getting the same table, right? 0, 1, 2, 3,
Yeah.
5, 6, 7, 8, 5, 6. Okay. We can replace it. Yeah, but here there will chances of some ambiguity, right? You need to check for both the conditions. So 2, 5, 7. Oh, is this a table you are getting? These 4 tuples?
Yes, sir. Yes, sir.
So here it is. My MVD. So 5. It must be 3 or here 7. 7, 3 also can be possible, right?
5, 3, 5, 7 both are covered. 1, 3, 1, 7 both are covered. So these are the possible combinations. And I'm fixing value of C and E as 2, 4 and 6, 8 because they cannot have any other value. 2 can only map to 4, 6 can only map to 8. So these are the 4 possible sets that I am getting.
See. So if we check for B multi-determine D, if we interchange the D value, keeping the beta value same, are we getting the same table? So let's check interchange here. It is 7, suppose. 7, and it is 3, right? And B should be same. B should be same. So 1, 1, 3, 7. Yeah, instead of 3, it is 7, 3. Okay, now check. 0, 1, 2, 7, 4. So do we have that tuple in this table? No,
0,
right?
1, 2, 7,
7, 4.
4. Yes, sir. Last value. T4.
No, no, this is 0, 5, 2, 7, 4, not 0, 1, 2, 7, 4.
Yes, it's there in the left side table of yours last.
Yeah, yeah. So in this table it is having, but we're talking about discussing about your table, right? This one. No, we cannot clearly say that this is applicable to these 4 tuples only. There should be 8 tuples, right?
Yeah, but we haven't interchanged the value of 2, 4 and built the table. So we can make the same table with the ulta combination of 6 and 8 and 1. So we'll get 8 values that way.
You'll get 8 values, yeah.
So if we, I mean, I'm just going by the which are all multi-valued and forming the combinations with that. And rest I'm keeping as fixed because they cannot be multi-valued. So I'm getting the same table, but I don't know if this approach will work for other problems.
No,
So
it will work, but you have to make sure you have to do it carefully, okay? Because here if you interchange 7, 3, then it will cause a problem.
Then I have to change the other value.
Other labels also, yeah. So anyway, you need to check all the 8 tuples.
Okay, sir.
Right.
Thank you, sir.
Yeah. Okay, any other doubt in this question?
Sir, I have one doubt, sir. Hello.
Yes.
Yes, sir. So whenever we are finding any multi-value dependencies, so our alpha, so we have a condition like you wrote, like T1 alpha equal to T2 alpha equal to T3 alpha equal to T4 alpha.
Okay.
But for B determining D, so if with all the tuples, I am not getting like B is our alpha here, right?
Right.
So I'm not getting same value for all the tuples.
For which, in which case?
So let's say my tuples are like given like 0, 1, 2, 3, 4, 0, 5, 6, 7, 8.
Hmm.
0, 5, 3, 6, 3, 8 and 0, 1, 6, 7, 8. These are my tuples. So my question is, if B is determining D, so the first condition is all these four
Okay.
tuples.
Just hold 1 minute. Yeah. So you're talking about, we are considering these two tuples and then these two, right?
Yes, I mean I am yes sir, considering that only. So for me to determine B multi-determine C, so I need to have all the four tuples. I mean T1 to T4 for B to be same, no?
No, wait. Let me clear this. So you are taking the given two tuples and the correct tuples from the option.
Correct tuples from the options.
Yeah. But here we know this is the correct one. Okay. So you keep
Yes,
solving.
I'm taking that tuple only.
2, 3, 4, 0, 5, 6, 7, 8, then 0, 5, 6, 3, 8, and 0, 1, 6, 7, 8.
Yes, sir.
Right.
So,
Yeah.
so for the second column, I
Hmm.
need to have, I mean, to be multi-determine D. So the column of B should have all values same, no, for alpha.
Yeah.
Like T1 of alpha, T2 equal to T2 alpha, T3 alpha, T4 alpha.
Yes. Right.
So, but here we can see there are two values. So,
Yeah.
yet it is multi-determining. How is it? How is that happening? I cannot understand.
Yeah. So here you already know the actual tuples, right? So if we create
Yes,
this combination, it will satisfy, because if you interchange the D value, keep the betas B same. So that is here 7. So instead of 3, it is 7. And here instead of 7, it is 3, because B is same. Now check 0, 1, 2, 7, 4. No, it is not there, right? 0, 1, 6, 3, 8. 0,
sir,
1, 6.
I am not talking about any other condition. I am just worried about the first condition. That is T1 equal to T1 alpha equal to T2 alpha equal to T3 alpha equal to T4 alpha. How we are getting that? For
That is why we are creating like 8 tuples. So in that we will
Verify
get
that only.
4 ones and 4 5s.
This is case 1. Here we are getting 4 tuples, and this is case 2 if we consider beta as 5. For B is 5 and here B as 1. 1, 1, 1.
So this relation will have minimum 8 tuples.
Yeah, 8 tuples.
And we have 2 tuples and we are guessing the other 2.
Yeah. So for that you need to solve you need to find out all the 8 tuples. Okay?
All the 8 tuples. Okay, sir. Now I understand.
I can also add here one more option, like option 5 and option 6, right?
Yes.
In that case, what you will decide?
Okay,
So
sir.
better to find out all the tuples, then check for the option.
Now I understand.
And it is applicable only when the relation R is having at least 3 attributes. Okay. Only we can check the MVD is applicable to that. If suppose A multi-determine B is there and we have only R1 as AB, so MVD is not holding true. So at least 3 attribute must be there. Because the by definition of MVD is will
be trivial otherwise, right?
Yeah. Okay. Any doubt in this question? Okay. Any other question in mock test?
Sir, question number 11.
Okay.
11. Yes.
Answer question number
15.
Okay, let
first
me
we'll take,
Yeah, 15 has been mentioned in the chat.
Okay, so let me discuss with first question number 11, then 15. Okay, let me share my screen. Sorry.
Is my screen is visible?
Yes, sir.
Yeah.
Okay. The question is, consider a string of pending block reference.
It was question number 11.
11, in which canonical cover we have to find.
Oh, okay, sorry. So let me discuss with first question number 15. Then we'll take question number 11.
Sir, may I ask one doubt?
Yeah.
Sir, the question that you showed previously, can we expect a question using MRU as well? And will
No,
that
no,
be done
only
in similar technique?
only LR will be used.
Okay.
Okay, so question number 15. Consider a disk having 128 tracks per surface, 512 sectors per track, and 256 bytes per sector. If the minimum numbers of bits required to access a sector is 21, then find the numbers of platter records. Okay, so let's solve this. Okay, so let's take number of platters. Equal to P. Then total number of surface will be 2 into P. Okay, so total number of sector will be total number of sectors will be 2 into P into 128. So yeah,
that is total number of tracks.
So that would be
Oh,
the
yeah.
tracks, no?
Oh, sorry. Track, then total numbers of sector will be 2 into P into 128 into 512. Okay, so you have to access total numbers of sector. Okay, so and total numbers of sector is 21. Okay, so what will be the, so to the power 1 into P into 2 to the power 7 to the power 7 into
8.
2 to the power 9, right?
8. 9, sorry.
Okay, so P into 2 to the power 17, and is total number bits to access a sector is 21. So we can say that 2 to the power 21 equal to P into 2 to the power 17. So P will be 2 to the power
5.
21 by 2 to the power 17. So P will be 2 to the power 4. So answer will be 16. So everyone got it?
So yeah, so basically here the total number of sectors will be 2 to the power n, where n is the number of bits. Yeah.
I want to add something.
Yes, please.
Yeah. Who asked this question?
Me, sir.
Can you tell me what is the disk structure?
Sir, in a disk there are a number of platters used.
Yeah.
Each platter has 2 surfaces.
Yeah, and where when the surface is not given that one side or both the side is information are recorded, then you have to assume that the both sided are the recorder is the platter we recorded information on the both sided. Okay, means we use the both the surface, right? After that, tell me.
After that, each surface has tracks, and each
divided into sectors.
Yeah, tracks are divided into sectors.
Yeah. Hence, each sector has the some different size is there.
Yeah. Each sector it is given to 56 bytes per sector.
Sir, what is the purpose of giving the size information, sir? Because we can do the sum even without that. So why have they given 256 bytes per sector?
That is the specification of the disk.
But is it relevant in this question?
No.
Okay, so is it's just
for the clarification, you have the correct concept or not?
Okay.
So can anyone tell what is the disk size then? Size of the magnetic disk?
It should be 2.91 into 256.
Yeah. P into 2 to the power 17 into 2 to the power 56,
2 to the power of
right?
29. Yeah, 2 to the power of 29 is the size of the disk.
Yeah.
Thank
Into
you.
2 power 8.
Yeah. You have to only multiply into here you can see the total numbers of the sector is P into 2 to the power 17 into 256, right? That is 2 to the power 8.
Sir, but will it not be 2 power 21 into 2 power 8 because you have two sides to the platter and each side has so many tracks and so many sectors. So it will be number of 2 into number of platters into number of tracks into number of sectors into number of bytes, right?
Same, no? This is same, right? So
Same.
Comes 2 to the 29. Yeah, same.
So you have a P there, okay.
Yeah.
So it'll be 2 power 21 plus 8.
Yeah. Into 2 to the power 8. Yes, Bindu.
Sir.
Yeah.
Hello, sir. Sir, one thing, sir, I mean, what kind of difficulty level can we expect from this part? Because this part was not thoroughly explained in the lecture videos, and we have all the sense that we get in the live sessions. So, how much difficulty can we expect from this this related problem sums?
If you know this concept of about the magnetic disk, I think that is enough to solve this kind of question.
Yes, sir, but I mean, in the previous term, in quiz 2 only, yes, in quiz 2 only, I saw a question about MTTF, which was, I mean, the concept used in that question particularly was kind of beyond our scope, and solution was also given in the discourse by Subhendu sir, which I did not understand at all because I did not know the concept. So can we expect that kind of questions from this part?
No, I think we are stick to the slide and the presentation, whatever we explained in the live session, that is enough to.
Hello, yes, Abhishek. So yeah, this particular part we have discussed in one of the live session, like magnetic disk part. So
no, sir, this question I know. I mean, similar type of question was there in GA also. But I am talking about another question which I saw in the previous term quiz 2. So after seeing that, like I don't have that concept to solve that problem. I can even share you the question also. I mean, I have the question with me.
Okay, so yeah, so on it was based on magnetic disks only, right?
It was, yes, sir. It was from this part. It was based on
mean time failure. Okay.
Yes, sir. So, I mean, for MTTF, if I get a question like a disk is running for 60,000 hours and it is failing for 750 times, so what is the average time? This kind of question, it is okay. I mean, it is very easy to solve. I don't expect this kind of question, but let's say related to this, I mean, I mean the difficulty level can be +5, -5, but if the difficulty level is +50 or +100, then we will not be able to solve questions from this part, because this part of all the formulas we get from the live sessions. I mean, there is no particular formula in the lecture video.
Yeah, so that okay, so this part is clear. So for mean time to failure part, you can refer to the slide. The simple calculation is there in the slide. So only that much difficulty will be there, not in like in the like previous case we have in the PDF.
Okay, sir, that is very I mean, good to hear, sir. Thank you.
In the slide only the 2 lines are mentioned, like if the mean time failure is this, then what will be that. So you can refer to that particular slide. Yeah.
Okay, sir. Okay, sir. So anything will be related to GA and practice assignment, right?
Yeah.
Sir, can you
Actually,
explain the MTTF once for revision purpose?
Yes, yes.
Sir, I'm not clear how the 2 power 21 came from the left hand side.
Okay. Yes, Pradeep, 2 to the power 20.
Hello.
Yeah, can I?
Yeah.
Can I explain?
Yeah.
Srinivasan here. So basically, it says that 21 bits are required to access the disk, which means the address has to be 21, which means the size of the disk, size of the plat, this thing, right? Each track, sorry, to access each sector, right, is you need 21 bits, right? And which means that 2 to the power 21 is a number of sectors. Is it clear? So because when you address, the size of the address is always dependent on the number of such sectors. So to start small, suppose you want to access 16, right? Anything 0, 1 to 5, 1 to 15, 0 to 15, you need 4 bits of address, right? And that is how it proceeds. So did I explain this?
Yes, it's clear now.
It means that number of bits are equal to total number of sectors. I'm right?
Yes, addresses will be 2 to the power. You have whatever value, right? Whatever you want to access up to 2 to the 8, which is 256, you can access.
Okay.
Hello. Hello. Am I audible?
Yeah, you're audible.
Is it clear to you what is the bit, how many bits are required? Right.
Hey, gate बंद कर.
Yeah. Hello.
Yes, sir, you're audible.
Yeah. Okay.
Sir, can you explain MTTF for revision purposes? Just to be clear.
Yeah, we'll discuss after question number 11. That will be fine, I think.
Okay, sir.
Yeah.
Entity which is there in the revision slide, right? So we can discuss that time.
Okay, sir.
Okay, yeah.
Sir, question number 11. You, sir. Okay, so let me share my screen. So is this question right?
Yes,
Hello?
sir.
Okay. So consider a relation R with attributes I, J, K, L, M, N with the following set of functional dependency. And the functional dependency given I K determine N, L determine M, N, J K determine L, K N determine J L, I K L determine J, and K M determine I N. So from among the following option, choose all the sets of the functional dependency which serves as canonical cover F on R. Basically, you have to find canonical cover. Right? Everyone got it? Hello?
Yes, sir.
Yes,
Okay.
sir.
Okay, so let's find. So we have to find first extraneous attributes. So that's fine. Okay, so functional dependency given IK determine IK determine N, then L determine M, L determine N, JK determine L, KN determine J, KN determine L, IKL determine J, and then KM determine I, KM determine N. Okay. So first let's find I is a extraneous attribute or not. So let's find closure of K. So closure of K, what will be the closure of K? Anyone?
Just K.
Yeah. What will be the closure of K? Just K, right? Okay.
Yes.
Okay, just K. So I is a not an extraneous attribute. Okay. So let's find K is a extraneous attribute or not. So let's find I closure. What will be anyone? I closure. What will be the I closure?
I only.
Okay. So I is a not an extraneous attribute. Okay.
Can
Okay,
you just say why I closure is only I and not KM? Sorry.
Okay, so see, I'm finding the K is a extraneous attribute or not. So if I closure we get K, then K is a extraneous attribute. If not get, then K is a not an extraneous attribute.
So you have the KM determine I, right? So
see,
given just K, we cannot identify anything else. That's why K's closure is only K. With individually with K, you cannot find it, right? You need something else with K.
Yeah.
Okay, so that's why the KM determines I is not a relevant thing here. Okay,
yes.
Got it. Thank you.
So then, okay, then IK determine N is a means redundant functional dependency or not. So without the help of this functional dependency, find IK closure. So what will be the IK closure? What will be the IK closure?
N.
Anyone?
N.
N.
With K and you have J.
Without the help of this functional dependency, remove this functional dependency.
JL.
Yeah. So anyone?
JL.
What?
J.
J and L.
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 And IKL will that's all.
Okay. So this is not a redundant functional dependency. Everyone got it?
No, sir. Could you explain it again?
Okay. So find IK closure without the help of this functional dependency. If we get IK closure N, if we get, then this is a redundant functional dependency. If we do not get, then this is not a redundant functional dependency.
Sir, how IK closure is JL?
Okay, so without the help of IK closure, so this, okay, no IK closure. No.
IK closure is just IK.
Okay, sorry. Actually, one student says so IK closure will be only IK.
Sir, but you get N from IK and from K and you get J and K and you get L, right? Last.
No,
we are not using that. Yeah, we are not using
that
the
is
first.
not used.
Yeah, not using. So only we get IK, not N. Yeah. Okay. So, and then see, this L determine M is redundant functional dependency or not. So find L closure without the help of this functional dependency. So find L closure. What we will get?
N.
N. L and then
L.
This much.
okay, so this is not a redundant functional dependency. Got it?
Excuse me, sir.
Yeah.
Sir, should we not remove all the extraneous attributes first and then
Yeah.
You see IKL is to J. If you remove L, you get IK to J. and from J you get N. So IKN then becomes redundant.
Okay, so can you repeat?
If you see IKL to J and
IKL to J, yeah.
If you remove that extraneous attribute, then you have IK to J, JK to L, L to N, which makes IK to N redundant.
Yeah, see,
ultimately we are removing all the function extraneous attribute only.
Yeah, see, there are multiple methods, so you can approach any. So you have to see also all options, which options are correct. So there are multiple methods. You can go means any methods.
So for a given functional dependency, multiple canonical cover can be possible. So the steps are like, first we need to find out the extraneous attribute. We need to remove that. Then we need to find out the redundant functional dependency.
Yeah.
Okay.
So
after
I understand.
Yes.
But in the method that we are following, it will take a long time, no? Because
it will take a long time. So
because of the options.
Yeah. So if you go to the definition of canonical cover, so what is it like? The set of functional dependency which can be inferred from the given functional dependencies, right? So if I able to find out all the functional dependencies from F in FC and vice versa, then I can say that FC is a canonical cover for F, right?
Yes.
Sir, but would that not be equivalent, not canonical cover? Can we, by that approach, we can say FC and F are equivalent, but can we also say FC is a canonical cover of F?
No, we cannot say, but for solving such question, we can take that approach. Because anyway, F is equivalent to FC, right? It is the minimal core of a given set of functional dependencies. So if you follow that approach, in the case of MSQ, it will help you. But MCQ, you can follow this approach because like only like in the real case, multiple canonical core can be possible.
So then also it will take a lot of time because we have to check all the options.
It will not take time if you see the options carefully.
Okay, just as a shortcut, does it help to start with, IKL, depends J, right? Because it has more. So can we start that, and then that way we can eliminate IK implies N.
So the first functional dependency in the given parent functional dependency is IK determine N. So if you go to the first option, so can you determine IK determine N from the first option, like first canonical cover?
No, sir.
So it is not there, right? So can you determine that if you take the closure of IK based on the FC? So can you get N? No. So first option is not correct. Now check for second option. So IK determine N is already there in the second option, right? L determine Mn is also there. JKL is also there. Now Kn determine JL. Can you check for that? In second option, Kn determine JL if you take the closure of FC, and vice versa also you need to check once it gets satisfied.
Yeah, that is there.
Yeah.
Sir, I use the same approach, like going by the options and eliminating some options.
Yeah.
Sir, can you continue this approach, the one you are explaining?
Okay.
Because I would like to see, sir, after some deleting the extraneous attributes, I'll have IKN and I'll have IKJ. So options B and D both would be correct. I would like to know, like, how would you choose?
Yeah. Okay, yeah. So okay. So L is extraneous or not? Sorry, L is redundant functional dependency or not? So
L is not extraneous.
Okay, not redundancy, right? Okay. Okay, then JK determine L. Okay. So find J is an extraneous attribute or not. So find K closure. So what will get K closure?
K only.
Okay. So K is not an extraneous attribute. So J is not an extraneous attribute. So K is an extraneous attribute or not. So find J closure. So what will you get?
J.
J only.
Okay, J only. So K is not an extended attribute. So JK determine L is a redundant functional dependency or not. So find JK closure. So what will get without the help of this functional dependency?
I guess JK only. Yeah.
JK only. Yes.
Okay. So then yeah.
So this dependency is not redundant.
Yeah. Okay. So see, there is a so find K is an extended attribute or not. So find N closure. So what will you get?
N.
So K is not an extended attribute. So sorry, and yeah. So then find N is extended attribute or not. So K closure, find K closure. What will you get?
K.
So this is not an extended attribute. So find this is redundant functional dependency or not. So K and find K and closure without the help of this functional
L.
dependency.
K and L.
So what will be that? Okay, K and L, right?
Yes,
MN.
sir.
MN.
Okay. Okay. So
From L we can get MN.
yeah,
From L.
we can N, right?
MN.
Okay. So sorry.
N is
K
already
N
there.
Sir,
M.
K N M L.
Okay, so from IKL we get J, right?
I is not there, sir.
I isn't there.
No,
Okay.
I.
Okay.
K and J.
Okay, so let's find.
From KM we'll get I.
From KM we will get I.
Okay, so KN, so K N L
And M.
Yeah, then
First now. Yeah.
yeah, M, then N,
Then I.
yeah, then I,
then
then
J.
J will
J.
J. Okay, J will say so. This is the redundant functional dependency, right? Right?
Yes,
Hello.
sir.
Yes.
Yes, sir.
So
Yes,
this
sir.
is a this is a redundant functional dependency. So if you take first, this is a redundant function. If you take first this K and determine L,
Then
so what will get without the help of this functional dependency? Sorry. If we take instead of K and determine Z, if we take first K and determine, so what will you get?
K N
K N
J.
L
L.
L. J.
Okay, so this is a redundant functional dependency, right?
Yes, sir.
Sir, we are including this K and determining
Sir, we will
L
arrive
or
at
not.
L. We
See.
will definitely arrive at L.
Yeah.
Yeah. So if we remove the first extraneous attribute, say IKL determine J, right? In that functional dependency, L is extraneous. Clearly, we can see that, right?
Yes.
Yeah.
So if we remove that extraneous attribute, then we cannot get K and closure as in J, right?
Yeah. Yes.
Sir, I'm still stuck in the previous step. So they are saying we are saying K N gives J is redundant because without that dependency we can still find everything else, including J. And now we are finding the closure of K N gives L. I mean, removing K N gives L and finding we still are able to get J. And so you're saying both are extraneous, but
Okay.
one
So
of the two is required, right?
okay. Yeah. See.
No, I think he's saying one of them is redundant.
Yeah.
Not both, right? One of them is
No. One of them is redundant, not both. So
okay, so
see.
either this or that, both are okay.
Yeah. So both are okay. Yeah. So
Once we have marked as redundant, we have to remove Kn equal to J from the picture, right?
Yeah,
Next time we shouldn't come back to it.
No. So
Okay.
actually, see.
So that is the difference between 2 and 4, right? So pair 2 and 4.
So
right?
that's why 2 and 4 is the right answer. So one of them is required. That's why I tell if you take first instead of this means if you take k and determine L instead of this k and determine Z, then we will get this is redundant, right? So that's why one of them is required.
Okay, sir.
Okay. Okay, so that's why you have to proceed.
So like this question is very lengthy. Kind of, can we
Yes.
expect these much lengthy questions in it?
Piyush sir said one shortcut, so you can follow that approach.
What, sir?
Piyush sir said on shortcut approach.
If there is a question like this, so you can check whether you can invert all the functional dependencies from the given canonical curve. Go to the each option, vice versa also.
Okay.
Sir, Piyush sir, so basically you're saying to find the equivalence if both are equivalent, like F covers FC and FC covers F.
Yeah.
Okay, okay.
So in this way, you can easily like remove the wrong options.
Yes, yes.
For MSQs, this is fine, but if they have MCQs, they can give equivalent option as well as canonical cover and then ask us to find, right? In that case, will this shortcut work?
No.
So in that case, you have to go through the long process only. Okay.
So simply you have to find first. You have to find extraneous attributes, then remove, and then you have to find redundant functional dependency. That's it.
Okay. But we can eliminate also, right, sir? Because we are getting Kn gives J and Kn one of this should be available.
One of the yeah.
So multiple canonical cover is possible, right?
Yeah, possible. But in cases where one of it should definitely be there, the other options can be ignored because it has excluded both Kn gives J and Kn gives L. So that cannot be an option. One of it must be there. So that way we can eliminate the other.
Yeah, we can eliminate.
Okay.
So in this way we can proceed. So everyone got it?
Yes, sir.
Yes, sir.
Okay. So there is one important question number 13. So anyone has doubt question number 13?
I couldn't even start, so I would I would be happy if you can explain it.
Yeah. So yeah, this is the question. So 1 minute.
There are 3 slots, sir. So first 3 to 4 can should be added. So 3 misses will come there itself.
Yeah. So let's
look for 3. 3 will not be found. So add 3 to the buffer. Then
okay. So block reference.
Yeah.
Then there is slot 1.
So first we'll try to find 3. It's not there, so we'll add it to the buffer. So 3 will come.
Yes,
then
slot 3.
First miss. Yeah.
Okay. So the numbers are given 3, 2, 4, 1, 3, 2, 4, 1, 4, 2. Okay. So let's insert first 3. So 3 is present in slot 1, slot 2, or slot 3 is not present, right?
Yeah.
Not.
So let's insert 3, and this will be
miss.
1 hit, 1 miss. Yeah.
1 miss. Okay. Then let's insert 2. So any of the slot is present 2?
No, there.
No, there. You have to add.
You have to add. So miss, right?
Miss again. Similarly in case of 4.
So 4. Any of the slot is present? Not. So 3, 2, 4 miss, right?
Yeah, miss.
Okay. Then 1 is
not there. Miss.
not there. So you have to find the least recent use.
3.
So you can see that 3 is, so 3 will be replaced. So 1, 2, 4, and this will be miss, right?
Yes.
Correct.
Okay. Okay, then 3, insert 3. So any of the slot is not present 3. So you have to remove
2.
2.
Yeah, so 1, sorry, 1, 3, and
4.
4. Yeah,
Miss.
miss. Okay, then
Remove
insert.
4.
Okay, remove 4. 1,
3,
3, 2,
2.
miss.
Miss.
Okay, then insert 4.
4,
4, 3, 2. Miss.
4, 3, 2, miss. Miss.
Then
4, 1, 2. Miss. 4, 1.
miss.
Miss.
This time hit.
Yeah.
So 4, 1, hit.
Hit.
Again hit.
4,
Yeah,
1.
4, 1, 2, hit.
Hit.
So number of miss.
1, 2, 3, 4, 5, 6, 7, 8.
8 miss. 2.
Number of it.
2.
2.
So 2 into number of misses.
16.
So
16 plus 6.
plus 3 into 2.
Yeah.
So I think 22.
Yes, sir.
Okay.
We are doing a hashing function also. So.
Hashing function.
So, if we get a wrong answer, probably you have ensured that we won't get 22 by mistake. So
Yeah. Yes.
So in this question, we followed LRU, right? So in the case of MRU, that is most recently used. So in that case, what we have to do? Yes, anyone?
So instead of 3, first we have to replace 4. Then we have to replace 2. Then we have to replace 1. We have to replace in the reverse.
Yep. Yeah, but we will have more hits actually.
More hits actually.
But it depends on the use case, no, sir? Because
Yeah,
in some
this case, in this case, we will have far more hits.
Yeah. It depends on the use cases.
But in both the cases, the new object would be appended the left and the old one would be pulled out in the right, right?
Your old one will be out of the buffer, so you will have to fetch it again if you're looking for it. So that will be a miss, and you are searching for the next number. But in this case, I think the misses will be low because immediate next value is the one that you just pushed out. So if you use MRU in this case, it will be more beneficial.
It depends on case to case, right?
Yeah, case to case. In this case, I'm saying it is beneficial. But in general, in this lecture, sir said LRU is known to be the beneficial, but I don't know how that works. So it also depends on how many buffer slots you take and how.
You see, LRU, any LRU can be beaten by just this formula, right? You have 3 and you repeat 4 again and again and again. You will continue to have misses.
Correct.
So that is the simple way to beat LRU.
Okay, sir.
Excuse me, sir.
Yes.
Sir, question asked what are the number of hits, and number of hits are 2, right? Then what is 22?
No. In the question we have asked about.
Question asks for a formula 3 in the
2 into
expression
number of
equation.
Yeah, there is slightly mistake. Sorry. So
you have to substitute the number of hits and misses in that form.
Yeah.
Okay.
Yeah.
Right. Okay, so question 11 discussed, 12 theory part, 13 discussed. Okay, 14. Anyone has any doubt in BST concept, binary search tree? In the revision slide, I have given 3 practice question. Anyone try to solve that?
Sir, I have
where is the where is the revision slide? Was it posted in the?
Yes, on Monday only we have released the revision slide for this quiz.
Okay, I will review it.
We have sent the announcement also regarding.
Okay.
Sir, there was one question in mock for decomposition. I mean, when given a, I mean, if it is a lossless decomposition, then it is R1, R2, Rn and R2, it is easy. But when we have 3 relations, I am not able to find out if it is lossless or lossy because R1 union R2 it should not be null. It should be the entire relation. We have some conditions like that. But when there are multiple relations, how do you do it, sir? There was one question like that in the mock.
So there is question number 4. Okay, we can discuss that.
Okay, sir.
Yeah. So in the question number 4, we have decomposed that relation R into 5 sub relations, like 4 to 5. So that part, right? How
Correct.
to check that?
Yeah, because when R1, 2 relations are there, we can find union and intersection and find out. But when there are multiple, how do you find the combination? That's the question.
Yes, just one minute. Is my screen is visible?
No, sir.
Question?
No, sir.
Yes, sir.
Visible, right?
Yes,
Yes,
sir.
sir.
Yeah, now it's visible.
Okay. So this question, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So what are the conditions for lossless decomposition?
R1 union R2 will give you the entire R. R1 intersection R2 is not null. And R1 intersection R2 is a key in either R1 or R2. This is for 2 relations. Two relations decomposed into 2.
So yeah. So R1 intersection R2 should determine either R1 or R2.
Correct.
So this condition we check while we decomposing any particular table, right? So we have a relation R having 7 attributes. So we cannot directly decompose into 3 tables, right? First we decompose it into R1 and R2, then we check, then we again decompose R2 into R3 and R4, right? So in this way we decompose particular table. So that's why we these are the conditions, because at any point, any time we are decomposing one relation into 2 sub relations only, right?
Okay.
Yeah. So just for this question, like how to check that part. So this question will take time. I will take only one option. So here you need to go through option wise. Okay.
Okay, sir.
Yeah. So let us take, okay, so first we'll take one correct option and one wrong option. That will be better. So first let us take a correct option, which is R3. So first you need to apply the condition on 2 relations. Let's say consider R1 and R2 here. So R1. Okay, so first, in this case, the first condition should be R1 union R2 union till R4 or R5. It should be equal to R. Like union of all the relations. So A, B, C, D, E, F, G, S, I, J. So it is giving all the relation attribute, right? Present in the R.
Yes.
So that is the first condition. Now in the second step, what we have to do, you can take any two decompose relation. Either R1, R2, R1, R3, R2, R4, any relation. But you should take in which we have the common attribute. So we can apply the third condition, right? So we can take first R1 intersection R2. So here R1 intersection R2 is A. Right? Correct. So from A, if I take the closure of A, can I get R1 or R2?
A can give, yes, sir, you can get.
Yeah. So A, D, E. Yes, I get R2 here, right? So now say R12 equals to R1 union R2. That is A, B, C, D, E. Okay. Now R12 is over. Now take R3 and R4. Is it common? Yes. F is there.
Oh, you have to first take union of R1, R2 and then intersect with R3 in this case.
Sorry, can you please repeat?
First, we have to take union of, for when you go into the next combination, first you have to take the union of R1 and R2 and then perform the same condition operation in R3. Okay.
So
okay.
Here I'm intersection of R3, R4. So F is there, right? Now if I take the closure of F, am I getting R3 and R4 or R4? Yes. So
you get R4.
Function determine, yes, FGH, which is equals to R4. Now say R3, 4 equals to R3 union R4, which is B, F, G, H. Now R5 is remaining. Okay. So either you can take R1 to intersection R5 or R3 for intersection R5. So if I take R3 for intersection R5, there is no common attribute, right? So we can take R1 to intersection R5.
But can we pick like this anything randomly as in 1, 2, 2, 3, 3, 4? Can we pick anything and then form an intersection?
Yes, yes. Because we are checking for the lossless decomposition, right?
Okay.
You have to consider those 2 relations which is having some common attributes. So and check whether we can determine R1 or R2. Suppose if we take R12 and we are not getting R1 and R2, then you can check for R1 and R3 combination also.
Okay, so we have to check all possible combinations and find out. It's not in
don't need
order.
to check all the combinations. If first condition is satisfying, then it's fine. Don't need to consider R1 and R3 again.
In all cases, it might not fit, right? So will the options be easily identifiable? Because if it's going to be complicated, then we have to calculate till the end, the same thing.
Once you, if you're satisfying this case, then you need to satisfy all the conditions.
Okay.
Like, even if you take R1 and R3, then you can try out, it will satisfy.
Okay, sir.
Like you need to check for that. Otherwise, you can take for different combinations also. Yeah.
Okay, sir.
So R5 is remaining. So R1 to R5, we have common attribute D. And if I take the closure of D from this functional dependency, we can get Dij, right? So that is R5. Now say R12 union R5. Okay, say R125 equals to A, B, C, D, E, I, J. Now check R125 intersection R34. So B is there, right? F is
B is there.
G is not there. H is also okay. B. Okay, so from B, am I getting all the? Let's see. If I take the picture of B, so from B, F, and from F, I can get G, H.
BF satisfies R3, so
yeah, so it satisfied R34, right? So yeah,
correct.
So all the conditions satisfied. So we can say R is R125 union R34, right? This is a lossless decomposition.
So does this mean first R1 was split into R2 and R5, and then R2 or R5 is split into R3, R4? Because at a time you're doing only decomposing into two relations. So with this, can we find the order of decomposition?
I don't think so, because I encountered a question where I did R1 and R3 first.
Okay. Yeah. So you cannot find the order of decomposition. Okay.
This condition we are following only when we are decomposing one table into two tables, right? Like this way. So we did not decompose this relation directly into 5 sub-relations. We decompose into R1 and R2. Then we check, then R1 into R3, R4, then R2 into R5, R6, like that. So for that, we follow this approach, right?
Okay. Because here we are getting a combination that is not in order. First R125 union R34. So we cannot say
order.
Order
will not matter also here.
Okay. Okay. Sir.
Yeah. Even if yes.
Please finish that. I had a question on the trees. Yeah.
BS tree. Okay. Yeah. So you can check for all the options like this. Okay.
Okay. Sir.
Yeah.
Yeah. So thank you for mentioning the revision slides. I found that. So you can choose to not answer this question, but there is the revision slide only talks about BST. So would B tree and B plus tree be not included in the quiz?
It is in week 9.
Yeah.
Oh, okay. So fine.
Syllabus is from week 1 to
28. Okay. Thank you.
Excuse me.
Yes.
Yes, sir. Can you summarize 1NF, 2NF, 3NF, BCNF, and like in short?
Okay. So any question is there in the mock? Let me check.
Yes, sir. Question number 10 is about BCNF.
Question number 10. Okay, so let's take that question. Is my screen visible?
No, not yet.
This question 10, right?
Yes, sir.
Okay, so this is relation now. So what are the conditions for 1NF? There should be no multi-valued attribute. Okay. So if in the question it is not mentioned that all the attribute have atomic domain, so you can assume that. Okay. So that relation is in 1NF. Okay. So now what is the condition for 2NF? Yes, anyone? There should be no
partial dependency.
Partial dependency.
Yes, partial dependency. So what are the condition for that? Like how we can say that there is a partial dependency in the functional dependency?
If the candidate key is alpha beta, let's suppose alpha beta, and there is also a relation called beta gamma in the functional dependencies, then it is a transitive partial dependency.
Partial dependency is basically prime attribute determining non-prime attribute.
So this we have alpha determine beta, right? And if alpha is a subset of candidate key,
Proper subset.
a proper subset of candidate key, sorry, and beta is any non-prime attribute, then we can say that there is a partial dependency. So relation R is not in 2NF. So in the case of 3NF, yeah, so it should be in 2NF. Like every higher normal form should be in the previous normal form. Okay, so like so 3NF should be in the 2NF. Then we can check for the condition. So what are the condition? Like means there should be no
transitive dependency.
Transitive dependency.
Sir,
Right.
so in TF we don't consider partial dependencies which we are getting through transitivity.
Sorry, in 3NF.
In 2NF.
Partial dependencies we are getting through
Transitivity.
No, that is not part of 2NF here.
No.
Okay, so we
check for the parent function.
consider direct dependencies.
Yeah.
3NF is stricter than 2NF, so we have an extra condition.
Yeah.
3NF is more strict than 2NF, so we have an added condition of transitive dependency is also being eliminated. So that's why 3NF came into picture. Transitive means non-prime attribute determining another non-prime attribute.
Yes, right. It's non-prime attribute determining non-prime attribute, then we can say there is transitive dependency. So relation is not in 3NF, right? But first it should be in 2NF. Then there should be no partial dependency. Now in the case of BCNF,
the left side should always be a super key.
It should be in 3NF first, and left side of any functional dependency should be super key. Yeah. So now let us
in a super key or full super. It has to be a super key by itself.
Super key. Yeah.
Not prime attribute, it should be a super key.
Super key, yeah. So for that, first you need to find out the candidate key, because from that only we can determine what are the prime attributes and non-prime attributes, right? So let us decompose this relation R. Okay, so like it is not mentioned whether it has multiple attribute or not, so we can consider that.
While at this, can we mention 4NF also, just for completeness?
Yeah. Sorry. Yeah. For 4NF, there should be no multi-value dependency. It should be in 3NF, and there should be no multi-value dependency. Like so, suppose if there is A multi determine B, and if we are having A, B, C as a sum relation R1, then it is having the multi-value dependency. So in order to remove that, what we can take, we can decompose this relation into AB and say suppose R1, 3S, BC. Okay. It depends on the functional dependency. Sure.
Yes, if A determines C or A determines B.
Sir, but in this case, we have that multi-value dependency.
No.
On R12.
No. For multi-value dependency holds true, there must be at least 3 attributes in the given.
Oh, sorry, sir. Okay.
So these are the 4 conditions, not 4 conditions. This is for first NF, 2NF, 3NF, BCNF, and 4NF. Okay. And yes, one more thing.
Sir, there was one statement that said 3NF always ensures lossless dependency preserving.
Yes,
so how are we saying that? Because BCNF does not ensure dependency preserving. So the level previous to it, how can it ensure dependency preserving?
See,
why it always
up to 3NF lossless and dependency preserving, and BCNF is lossless but not dependency preserving.
May or may not be dependency.
Yeah.
So yeah.
But
BCNF
2NF
is
also does not ensure
No,
dependency.
4NF also does not ensure. Up to 3NF only we can ensure that dependencies are preserved.
No. Even in 2NF, I searched and it said 2NF also does not ensure. 2NF is the previous of 3NF, right?
Mhm.
So that also does not ensure. So only 3NF, what is so specific about it that it always ensures dependency preserve?
No, 2NF is also dependency preserve.
Okay, always.
Yeah, up to 3NF, 1NF, 2NF, and 3NF. Up to 3NF, lossless and dependency preserve.
Okay, sir. Got it.
And BCNF, lossless, but may or may not dependency preserve.
So suppose in 2NF, there is no partial dependency, means it is in 2NF, and it is not dependency preserving, means it's like there must be transitive dependency there, right?
Okay. Got it. So as far as we have the partial dependencies around, so non-prime to non-prime is possible, so we can have it as a unit.
Yeah.
So when it comes to BCNF, you're eliminating that possibility.
Possible.
Okay.
So BCNF is more stricter than 3NF. So, so here is one more condition, or left hand side should be super key also, right? In
Yes,
here,
yes.
we are removing that this condition in BCNF.
Okay, so got it.
Okay, so we take this example only. So relation R is given. So no information is there whether it having multi-ordered attribute or not. So we can assume that all the attributes are atomic. So no multi-ordered attribute is there. So we'll check for the 2NF. So for that, we need to find out the candidate key. So how to find out candidate key here? So there are two approaches. So first one is we always recommended that we need to check the attribute which is not present on right hand side of any functional dependency. If it is present, then we need to take the closure of each attribute and a set of attributes, and then we need to find out whether we can get all the attribute or not, right? So yes, anyone here? What is the candidate key? What are the candidate key?
Sir, I think it is M, Q, OP, and ON.
Yeah.
Yes, sir, correct. Except N everything.
So P is there, M is there, Q is also there, N is, so all the attributes are there, right? So we need to take the closure of M plus, N plus, O plus, P, Q. So from M I will get M, N, O, from N, P, from O, P, Q. So this is the candidate key here. From N, only NP I can get, right? From
Yes.
O, only O.
Don't get anything.
From P, only P. And from Q from M, right? And from M, I can get all the attributes. So this is also the candidate key. So here, M and Q are the candidate key. Now, if you take the combination of any attribute with this candidate key, it will be a super
So OP
key, right?
is also candidate key, so because that is also a minimal set.
Yes,
OP and ON also.
Yes, I'm coming to that. Yeah.
Okay.
Yeah. So here we got two candidate key, M and Q. So if you take the combination of attribute with any candidate key, so it will be a super key, right? So it will anyway give us all the attribute relation. So what are the attributes are remaining? N, O, and P. Now there are three possible combination: NO, OP, and NP. Now let us take the closure of this. Okay. So from NO, can we get all the functional dependency? Let's see. From NO, I can get P. From P, from OP, I can get Q. And from Q, I can get all the attributes, right? So NO is one of the candidate key. Now check for OP. OP, I get
P
Q.
and N can be used interchangeably.
Q,
So
yeah.
by augmentation.
So we all get, yeah. So NP from NP.
NP itself is redundant. So N implies P, yeah.
Yeah, right. So we have 4 candidate key here, right? So candidate key are, so candidate key are, I'm writing it over here, M, Q, NO, and OP. So what are the prime attribute here?
Everything.
All the attributes are prime attribute, right? So is there any partial dependency here? Which
NP.
One of,
And NP, sir, I think it is a partial dependency.
NP is the partial dependency.
But
right?
NP is not there, no? So we are not putting NP, right?
No, no. See, so let us check is there any partial dependencies here or not, because we are checking.
No partial dependency, sir.
Okay.
Because all the attributes are prime. There is no non-prime attribute. So if n determines P, P is prime attribute. So it cannot be a partial dependency.
And no transitive also, right? So because everything is come to prime. So 2 and 3 automatically get checked, no?
Yeah.
Am I mistaken in saying that?
No.
Yeah, all attributes in the set are prime attributes. So there is no non-prime to non-prime or prime to non-prime. So everything is. So till 3NF, it is satisfying.
Yeah, so we need to check for BCNF also, right?
Yes.
So for BCNF,
N gives P is an anomaly because N is not a super key.
yeah. So let's try to decompose this relation R into BCNF also. Okay, so this is not satisfying my 3NF BCNF condition.
What prime attribute specifically means?
Prime attribute means the attribute which are present in the candidate key.
Okay.
M, Q, N, O, and P. So all the attributes are present in the candidate key. So these are the prime attributes, and non-prime attributes are the remaining attributes in the given relation. But here all the attributes are non-prime attributes. Okay.
Okay.
Yeah.
So how did you find that NO and OP are candidate keys?
Okay. So
Showed
first we
it,
find.
right?
Yeah.
I missed it. I didn't understand.
So first we take the closure of all the attributes and see we are getting all the relations are getting all the attribute in the relation R or not. So in that we get M and Q as a candidate key. So 3 attributes are remaining. And we need to take the combination of this NO, NP, and OP, right? Now take the closure of this set of attribute and check whether we can get all the attributes or not. If you are getting it, so that is a candidate key. So yeah, so NO and OP we are getting all the attributes. If we take the closure of this, so this is a candidate key. Okay.
Okay, so got
you
it.
can try that. Yeah. So this violating our condition. Q is a super key because every candidate key is a super key, right? So satisfying our condition. This also and this also. So we have problem with this NP, right?
Because the left side is not a super key.
Not a super key. So we need to decompose this relation R. So how to decompose that relation R such that we'll not get this. We can remove this. What we can say? Yeah, we can get the left hand side as N. So
Find closure of N.
Yes, I can find out the closure of N. So from N, I am getting P. No, right? So I can take this as one of the relation, that is R1. Say R1 and P. Now, if you remember, we just discussed about the lossless decomposition condition, right? So what is the first condition? R1 union R2 must be equals to R, right? So what should be the attribute of R2?
Sir, MOQ.
MOQ must be there, right? Another condition was R1 intersection R2 must give us R1 or R2. So here, if we take N here, and if can we get R1? Yes. And instead of N, if I take P, common attribute, so will I get R1 or R2?
No.
No, right? So we need to consider any attribute here.
Sir.
Yes.
Sir, 4NF is R should be in BCNF and then no MVD.
Oh, here. Okay. So it should be in BCNF. Sorry. So R1. Okay. So till now, everyone got this, right? How I decompose this relation?
Sir, I'm little bit confused. Can you repeat once again?
Okay. So we have this functional dependence is not satisfying the BCNF condition, right?
Yes.
So we need to decompose the table, this relation.
Yes.
So how to decompose that? We need to take the closure of this attribute N.
Okay.
So in this way, we are getting NP, right?
Yes.
I can make this as a R1, like one of decomposed relation. Right, but we always aim for the lossless decomposition right?
No.
Yes.
Yeah.
There should be no.
So then I have to check the conditions of R1 union R2 holds R or not, and the second and third condition, right?
Yes, yes.
Okay, okay. Thank you, sir.
So M, O, Q, and M. Okay. Now, what are the functional dependencies applicable to this R1? That is N determine P. And here Q determine M, OP determine
Q, and M determines
M determine NO.
Okay. Yes, sir. Thank you.
So here we preserved all the dependencies, but there is just a coincidence.
No, we decompose this relation. That's why we have preserved all the functional dependencies. The question is asked about the relation R.
Yeah, but BCNF we don't have to preserve.
Sir, OP
In BCNF,
determines
it is
Q will
lossless.
not be preserved.
Wait. Yes, I got it. Yes, who was asking this question?
Srini wasn't here. So BCNF, the dependencies don't have to be preserved.
Yeah.
But in this question, they happen to be preserved.
No, it is not happening. I didn't wrote it. See, here, what are the applicable functional dependencies for R2? N determine P is there, Q determine M is there. So I write OP determine Q, but P is not here, right? P is not present in R2, so it is not applicable to R2.
Okay.
So M determine NO is also preserved. So this functional dependency is not preserved here. OP determine Q. You need to check, like this is not the proper condition, but for that you need to consider. Okay, so what are the what is the algorithm to check whether the dependency is preserved or not? Is anyone? How we check that whether this function dependency is preserved or not? So first we decompose the relation. We write what are the applicable functional dependencies. So this functional dependency we need to check whether it is preserving or not.
It's not even, there is no relation that has both of them anyway. So it's not preserved.
Yes, there is one, yeah.
Sir, we first find the closure of functional dependency, which is given. That is, we will find canonical cover of that dependency, and then we will check whether the decomposed relation are satisfying all the dependency given in canonical cover. If not, then we will say that it is not dependency preserving.
Basically, a relation, it should satisfy the functional dependencies within one relation itself. It should not be a union of two relations. So it should be atomic, the dependencies.
It should not satisfy the two relations.
No, it should not. It should be the functional dependency should be solvable with a single relation of the decomposition. You should not combine two relations to satisfy the functional dependency. For instance, in this case, we have OP to Q, but P is not available in the second relation. So we have to join the R1 and R2 to find OP to Q. So such dependencies should not be there. So it should be dependency preserving within the same relation.
But we are not done here. We need to check whether it is preserving or not. From
it is not.
Directly we cannot infer, right?
Sir, I think first we have to individually find the closure of R1.
Okay, sir. Sir, there is a question in quiz 2, previous term quiz 2. I can state the function dependency and you can show us means how it is not dependency preserving. Should I state you?
Here only we can find out now. Okay, you can tell that afterward. But
okay, but
yes. After that, sir.
Sorry, will my shortcut not work because there is no relation that has both O and P. So that dependency is not preserved.
Can it should be OP and Q, not just O and P, OPQ.
OPQ. You
need
to check.
Actually, F1 union F2's closure should be equal to F closures.
Yeah, you are right. So basically, dependency preserving means parent table functional dependency are preserved in child table or not. You have to say.
Correct.
So if you have doubt in dependency preserve, I can explain, with the help of one example if you have doubt.
Yes, sir. Can you please do that?
Okay.
So can you write down the formula first? How the closure of F relates to the closure of F1 and F2?
Yes. Just coming to that. Yeah. Okay, so first we'll complete this. Okay, so till now we have just decomposed relation BCNF, right? So this functional dependency is not applicable to any of the relation, right? So we need to check whether it's preserved or not. So for that, what are the possible functional dependencies that I can derive from this R1 based on the parent functional dependency? So for that, we have two attributes. We can take the closure of n plus. So from n plus, I can determine np, right? Now, if I take the closure of p, can I determine anything? No. So only applicable functional dependency is n determine p. So it's already there, right? Now here, in the case of F2, so we need to take the closure of M and Q. We already know that it is a candidate key, so it will give us all the relation, right? So the rest is like O and N. Now let us take the closure of O. Are we getting anything? No. Then N. No. Then O N. From O, are we getting anything?
Yes, sir.
O N P.
Everything else.
OMP, yes, we are getting. So this is satisfying, right? So I can say that from OM, I am getting, okay, wait, ONP.
So ON is a candidate key, so you will get everything.
So every ON, M, and Q, right? In R2. So I can say ON determine MQ. It means ON determine M also, and ON determines Q also, right?
Yes.
Now, if I take the F1 union F2, means here n determine P from relation R1, Q determine M, M determine NO from this relation R2, and we got this, right? Two new functional dependency. It is ON determine M and ON determine Q. Now, based on this 5 functional dependency, you need to check whether we can derive this functional dependency or not. If yes, then dependencies are preserved. If not, then dependencies are not preserved. So can we get OP determine Q here from these functional dependencies?
No, sir.
Yeah, so that's why dependencies are not preserved here.
It's a long calculation, so no shortcuts. Okay, no shortcuts. Okay.
No.
So, but sir, we can do the shortcut. No, so for example, you can see n gives in the main relation. You have n gives p. You write R1 and R2 separately. Is n gives p derivable from either R1 or R2? We can. It is derivable from R1. So NP is resolved. Q gives M. This can be achieved through R2 itself on its own. You don't have to do any union. M gives NO is also achievable just through R2. So it is possible. But OP gives Q. If you just use R1, you cannot derive this because R1 has only P and N. And if you just use R2 also, it is not derivable because P is missing. So this you have to take the union of these two to arrive at this. So you can directly say it's not dependency preserving, right? So you can just do the reverse engineering.
No, so you are meaning, so if you take R1 union R2, right?
No, if I'm saying if P is missing in R2 and O and Q is missing in R1. So this particular relation cannot be derived individually using R1 or R2.
Right, yeah.
So it is not possible to achieve this functional dependency using R1 or R2 individually.
Individually, it is not possible. So that's why you're following. No, Adavi, you cannot like directly say that.
Because that's what we are doing, right? So F1 union F2 will not give you OP and Q. So what I'm saying is OP and Q is not available in R1, neither is it available in R2. Isn't that, it's just the reverse of what we are doing. So that is easier, right? Because we have the functional dependency with us. We have the two relations with us. So we can see if this dependency is either available in R1 or R2. If it's not there, then not dependency preserving.
But let's say if the union
in some cases we get these kind of relations, dependencies,
if it is
by applying transitivity or some sort of.
But even in that case, it will be resolvable within the same relation. For example, if you're saying transitivity, M gives N, N gives P, it will all be in the same relation again. You don't have to look for any.
Not in the same relation. In F1 union F2, we get dependencies from both of the decomposed relations, right? So by applying transitivity, we get the dependencies which are not particularly not in R1 or not in R2.
No, that's not possible, right? Because if you're doing F1 union F2, Can you quote an example? Because in all cases, because I'm just saying the reverse of this. You should not introduce any new dependency, because if it's transitive dependency that you're talking about, that transitive dependency should still be a part of either R1 or R2. You cannot combine these two and form a transitive dependency. That's not allowed, right?
But the formula is closure of F is equals to the closure of F1 union
F1
F2
union
union
F2.
F3. Yes.
Yeah.
So what if you can obtain OPQ from F1 union F2? What if
that's not allowed, right? Because F1
it
union
is allowed.
F2,
We are taking the union, right? After union, we are doing a closure.
We need to find out whether we can derive this functional dependency based on this F1 union F2 or not by using these 5 functional dependencies. Like there is some examples also, we will get this functional dependency. Yes, Adhavi.
No, my question is, when you're saying F1 union F2, it's still a disintegrated part. It's either from a relation from F1 or a relation from F2. It is never you pick one attribute from F1 and one attribute from F2 and then form a relation. That is not allowed, right? That's what I'm asking. That's not possible. So you can do the reverse also. You can say that if this is either available in R1 or R2, then it's acceptable. No, but none of these can give you OP gives Q. You can give a counter example, sir, because in all cases I saw, I'm able to do the reverse of it.
Actually, one example used in week 6 tutorial 3. In that case, if you watch that, your point will be clear.
Yeah, can we look into that, because even there I solved that, but there also we have the same.
You can use that example used in week tutorial 3 week 6. The question number 1, I guess.
There is one problem in the practice in the slide also, practice problem. I think Aditya solved that. I checked the solution also. So in that you can see that. Wait, let me check that question.
Because I'm not able to find a counter example where this is not true. Everywhere this holds true. So that's why I said reverse is also.
I can say I have written here the example. You can you can write it down. I'll say.
Advi, hello.
Yes, sir. Yes, sir.
Yeah, I will give you one counter example after this. Don't worry.
Okay, sir. Okay, sir.
Yeah.
Okay, so there is one question in the slide, like practice problem is there. And that we can.
Oh, okay, sir, can I take this?
Yes, Subin. Do you have that question? Yeah.
Yes.
Better to discuss now.
Yeah. So I think this is a. I think okay. So first I will discuss what is how to find dependency present. Then I will give one counter example. Right.
Okay.
Right. Okay. Okay. So see. Okay. So most of the students have problem in dependency present. So.
Yes, sir.
Okay. So there is a relation R, and the attributes A, B, C, D, and the functional dependency given A determine B, B determine C, C determine D, and D determine B. And the decomposition relation are R1 AB, R2 BC, and the R3 BD.
Okay, sir.
Okay. And the so we have to find a closure with the help of this functional dependency. So what we'll get?
Everything else.
So A, B, C, D. So but the R1 present only A and B, right?
Correct, sir.
So A determine B already. So we can write A determine B, right?
Yes, sir.
Okay, then we have to find B closure with the help of this functional dependency. This functional, what will get?
C and D.
Okay, C, D, C, D,
and B again, but yeah, that's okay.
B, right? Yeah, right. Okay. So B determine only B, right?
Correct.
Okay. Then R2 relation B and C. So already B determines C. We can, if we find B closure, what will get?
C closure, right? C will give me D.
No, only B closure.
B closure in this
B and
relation.
C. B, C.
Yeah.
B, C. So we can write B determines C, right?
Yes.
Okay. So let's find C closure. So what will get?
C gives
D.
D and B.
C, D, and B, right?
Yeah.
So you can write C determines B, right?
Yes.
Okay. Okay, then find B closure with the help of these functional dependencies. Okay, so sorry. So
you don't have anything B here.
Yeah, so okay, so B, C,
D.
Okay, so
C and D. Yeah.
B, C, D. And yeah, so B determine D, right?
Yes.
Okay,
And D
D closure?
B.
DB.
Okay, so DB.
And then
So,
C and everything, yeah. But
yeah, so determine B. So if you say A determine B is preserved, right? You can find from this. B determine C is preserved, right?
Yeah, correct.
And D determine B is preserved, right?
Yes, correct.
So we have to find C determine D is preserved or not. So find C closure with the help of this
No
functional.
need, no, sir, because C determines B is already there in R2.
No,
C
C determine
D.
C determine D. I'm
determine D.
talking. So what will we get? Find C closure with the help of this functional dependency. What will get?
B,
B,
C, B, D. Yeah.
D.
C, D. So C determine is preserved, right?
With the union. With the union. Yeah. Okay.
With the union, yes. But otherwise.
Yeah. C determine it is preserved, right?
Yes.
Okay.
Sorry, how is it preserved, sir?
So see, find C closure with the help of this functional dependency.
B, C,
So
D,
what?
correct.
So C did B.
Correct.
Then from B we will get B determine D. So what will get? B, D. So you can write C determine D, right? From this.
So you are essentially doing a union of R1 and R2 and R3.
Yeah.
F1 union F2 union F3, and from that functional dependencies, we are checking whether we can derive that functional dependency or not. So if
So everyone got it. Functional dependency present, right?
Yes, sir.
But so you're saying that this unionizing is allowed, as in you can, because the C determines D is directly not derivable from R2. So you're unioning R2 and R3 and then finding C gives D. So you're saying that.
Yeah.
This is the method to find to check whether dependency is preserved or not. We need to check anyway. We cannot directly say that from the decomposed relation. Like in the previous example, it was not preserving, right? Now here it is preserving, right?
Because so if I understood the dependency preserving means that you don't have to unionize any relation to get that value. But here we are taking a union of R2 and R3. That's why I was confused. How can this be called dependency preserving? Because you're not preserving the dependency atomically with a single relation. You have to make a
Actually, I have explained in I think week 5. With the help of one example, we can refer to week 5 live session. I think open live session. I did not remember, but I will post in the discourse.
Okay.
Yeah. Okay. So
in lecture also, professor told us when a relation is not decomposed, then we can use that directly. But if it is decomposed, then we cannot use the simple process. The professor elaborated that.
Okay, so when in decomposed relations, you have to do this union and find out. But
you have to do that.
Okay, got it. Thanks.
Okay, so you got it, or you have any doubt?
Yes, got it. Thanks.
Yeah, because in the original table we are getting the functional dependency C determine D. So if I want to find out the D applicable condition on C, then I need to join two tables, right?
Correct.
R2 and R3 in SQL, right?
Correct.
Yeah, that is the case.
Got it. So it's like you have decomposed it multiple times and you have to unionize one of the other to get the relation. But it's not a union of everything, so it still is fine.
Yeah.
There is one also tutorial regarding dependency preserving Bhaskar sir given. So you can watch this lecture. It is very helpful.
Okay, sir.
So please watch. I think week 6.
I think I saw that week 6 tutorial, but my perception was different at looking at the lecture.
Yeah, clear. Please watch Bhaskar sir tutorial, so you can.
Okay, sir.
So there is this is a note I have. Some require natural join, right, to check the preservation. So a natural join is allowed to check preservation or dependency.
Natural join, no.
No,
I
we
think the
cannot check
concept of
the.
natural join is for lossless and losses.
Yeah.
So no, under dependency preservation, I have the notes. Some dependencies can be checked within the individual relations, right?
Yeah.
Some might require a normal join, natural join.
No.
Like we have done now.
So you have to closure. See,
we are not performed the natural join here. We have taken the union of F1, F2, and F3.
See, T determined D is not preserved, right? Hello.
Yes.
So we have to closure of. So you have to take closure of C closure with the help of this child table functional dependency.
Oh, okay. We are not even doing a join. Okay.
Yeah. So what will get?
Just a union.
So C closure will be C, then B, then from B determine D, we get D. C, B, D. So we can infer from that C determine D. Right?
We are not joining, yeah. We are taking the
So
union of
you have to
functional
remember F closure equal to F1 union F2 union F3 closure.
Yes, that is not actually closure. You can say F dash also, right, Subhendu?
Yeah.
Okay. So you're introducing transitive dependency to achieve this, and still that is allowed. Got it.
Yeah. So, Pradeep, you want to discuss that MTTF, right? Or any other question in the mock, right? If you have any doubt.
No, sir, we can go for MTTF.
Okay.
Sir, I have a very small question regarding 3NF decomposition. Can I ask or should I wait for after this?
Okay. Can we take this first? Then you can.
Yes.
Okay. Now we will discuss about the what is one concept the student confused about MT, F, right? And what is the full form for mean? I'm audible, right?
Yeah.
Mean time to fill. So what does that means? This is the average time for the any device continuously run without any failure. That is the average time. So let me give an example. Suppose this is a system and the system consists of the 3 disks, right? A, B, C. And this is the time this is run continuously without failure. That is suppose that is the 50 and this is the 150 and this is suppose let's take 250, right? So can you anyone tell what is the MTTF for that? That is the simple mathematics only. You have to take the average time failure. So the
average or lowest?
150.
Yeah.
Is it 150, sir?
Yeah. That is the you have to take. Any confusion? Someone ask something.
No, won't it be the lowest? 50 yes.
Lowest? No. That is the average time.
You mean
have to, yeah, mean. That is also mean or the average time to the failure. Right.
Yeah.
That 150 divided by only 3 devices. So you have to take for the 3.
Okay. This assumes that any one of the devices is enough for the system. Not all are needed for the system.
Yeah.
Okay. If all are needed for the system, it will be 50. Okay. That's why.
Yeah.
Yes.
So this is for the one device, right? Hello?
Yes, sir.
Yeah.
Or is it one device or one disk?
One system.
Okay.
Right. And that is
50,
150. I think this is clear to everyone. What is the mean time to the fill?
If they straightforwardly give these hours, it's easy. I hope.
Yeah, you can write this is an hour.
No, I'm saying if they give it in some other terms like the torque of the disk or something like that, then we have
no. That's this is only the simple problem is.
Okay, sir.
Yeah. So in the lecture we have not discussed about that, right?
Yeah.
Torque and the frequency part.
It was there in one of the practice assignments I saw where they were talking about the torque of the spindle, and we had to calculate the time taken and then calculate MTTF. That's why I asked.
Yeah, there was a complete physics question there.
Yeah, it was there.
In this January term, right?
Yeah, in this semester only we had in this I think week 6 practice assignments. It was there where they gave the speed and they had to calculate the time.
To find out the time, yeah. Of course.
Yeah.
Okay. One small suggestion: this disk geometry, right? Would it help if you have a tutorial session? Because the live session, I would watch it. I definitely miss the live session. I will watch it, but tutorials in everybody will watch anyway, right? So that probably might be useful. Maybe in the next term you can suggest that.
Yes.
Because there are quite a few numerical questions on that. A tutorial will be useful.
Yes, we'll note down that. Yeah, if possible, before the end term, we try to release that.
Okay, sir. Thank you.
Yeah. But we have discussed this in detail. Like as of now, you can refer to the live session. We have discussed like from basic. Yeah.
So the DBMS live sessions, I always have a clash, so I end up missing them. I attend the other live sessions, other courses, and so I will watch the recording and get the.
But yeah, like we'll take your request and we try to record the tutorial before the end time. Yeah. If possible. Yeah. Thank you. Okay, so as like someone is asking any doubt regarding decomposition.
Yes, sir. Sir, in 3NF decomposition, after we decompose every functional dependency that violates the 3NF rules, at last what we have to do is we'll have to check if the candidate key belongs to any one of the relation. If it doesn't, we'll make a new relation, right?
Candidate key belong to one of the
candidate, like the key of the entire relation.
Yeah. So basically in 3NF decomposition, first you have to find canonical cover. Then for every functional dependency, make one relations. Then last you have to check means key of the candidate is present or not. If not present, then you have to make another relation candidate key.
Yes.
That's it.
So my question is, sir, what if there are multiple candidate keys?
So if there are multiple candidate key, then you have to see this. Means one of the you have to make one relation or any one candidate key.
Anyone. Okay.
Yeah, anyone, and we have to also see the lossless join properties. So if lossless join is satisfied, lossless or not. So if suppose one candidate key is not lossless join, then you have to make another candidate key. So you have to see that's but lossless join.
Yeah. So there can be multiple decomposition also for a given table, like based on the candidate key. But you need to check like if we consider one candidate key, then are we getting the dependency preserving like or not? Like in BCNF we may get or we may not, right? So we need to check that part.
Okay, sir. Okay.
So in the one of the live session, I have discussed the whole example regarding that only. There are multiple candidate key and I have taken one of it and I have proceed further.
Okay, sir. I will take a look at that.
Okay.
Sir, while decomposing any anomaly for taking it to the next normal form, so we only decompose the one that is having the anomaly, right? The rest should stay intact, or can we decompose that also? I know we can add relations, but the existing relations, let's say in 3NF, and there is one particular, in our case, it was n gives p, right? So we only touched that. We only decomposed n gives p to get the BCNF. So that is that a unsaid rule that we only have to decompose?
Because so if you decompose R2 is already in 2NF, right? Sorry, 3NF.
Okay.
3NF, BCNF. What was
so, but we can add relations if required, right?
Yeah.
Okay. Good.
we can add the relation, but we need to check. It must be not redundant, right?
Yeah, only if it's required.
Yeah. Okay. One question from BST. Okay. In the mock, it is there, right?
Yeah, one of the question is there.
Okay, I will take that. Question number 14, right? Is my screen is visible? Right? Who asked this question? Anita, right?
Yes, sir.
Yes. So in BST, what we follow generally. So suppose this is a correct option. We will try to insert the record in this particular form. Now, first we take the 64 as a root node. Then we need to check whether this number 31 is greater than 64 or less than 64. If it is less than 64, then we mention it on the right hand side. If it is greater than 64, then we can write it on the right hand side. Oh yeah, okay, right hand side this time. And in the case it is less than, we can write it on the left hand side. So 31 is less than 64. So here it goes to left hand side. Now 20, compare 20 with 64. It is less than 64. It is less than 31. Again, it will go on the left hand side of 31. So that is 20. Now 52. Now 52 is also less than 64, but greater than 31. So it will come on the right side. It is 52. Now 10. 10 is less than 64, 31, and 20 also it will come on the left hand side. And so, do you have any doubt in that? What is your actual doubt in this question?
Yes, sir. I was not able to get the correct solution, sir.
Here you need to go through the option. You need to check you need to construct the tree for each of the following option and see whether it is satisfying our this tree or not.
Okay, sir. Thank you, sir. Thanks, sir.
Yeah. So in this way you can try. Simple is that just compare. If it is less than, then it will go on the right hand side of that particular element. So not sorry, right hand side, left hand side. And if it is greater than, then it will go on the right hand side. So just one question here. What are the element at level 2? Elements at level 2.
31 and 96.
Huh?
So 20, 52,
20,
79,
20, 52,
79,
79, 98. Yes.
79 and 98, right? And
Yes.
what is the height of this
Yes.
tree? Height of this
Height of the tree is 3. 3.
3. 1, 2, 3. Yes, height is 3. Right. So this is the simple concept. Yeah.
Sir, is there any difference between the height and level?
Yeah. So level, this is level 0. This is level 1. This is level 2. And this is level 3.
See, maximum level is the height of the tree.
Yeah.
Okay, sir. Got it.
Okay. Any doubt? I think we have covered all the questions. 16, 14, 15, 13, 11, 10. Question 9 is similar that what we have discussed earlier. Lossless as well as dependency preserving. Yes, Adavi, you can try that question number 9. Okay. In that we have to take the F1 union F2 and then see whether we can get that functional dependency or not.
Sir, can you say which question you are screen?
Question number 9, mock test. Do you want me to share that screen? Share question. You can check question number 9, mock test. Mock test 2. Then, okay. Question 5 is okay. Question 4 we have discussed.
Sir, the mock test that happened just now, right? This
is mock quiz 2, question number 9.
I was able to solve it with my logic. That's why I couldn't actually know why it is not allowed. That's why I asked. Decomposition, right?
Yeah. Dependency preserving one.
Yeah. Just a second. Let me pull out that question.
Okay. So anyone have any doubt in mock or any in the concept of any week?
Sir, I just want to confirm one thing.
Yes.
In BCNF, we make a new relation for every offending functional dependency, correct?
Every?
Everything that violates the rules of BCNF, everything, right? But in 3NF, what we do is we first compute a canonical cover and then make a relation for every functional dependency inside the canonical cover.
See, for direct decomposition to 3NF, so that is the algorithm. We can also go to first NF, then decompose into second NF, then go decompose into third NF, decompose into BCNF. Actually, Professor tell you can directly decompose into 3NF. So that's the algorithm.
Yes. Who asked this question? Sorry, I missed his name. Okay. So can you please repeat? You have any doubt in that? Like,
Sir, I just wanted to confirm one thing, sir. Sir, in BCNF, what we do is every functional dependency that violates BCNF rules, we will separate it out and make a relation out of it.
Violate 3NF rules, right?
BCNF.
Oh, BCNF, yeah.
Yes, but in the case of 3NF, first we compute a canonical cover of the functional dependencies, and for each and every functional dependency in the canonical cover, we make a relation.
So yeah, so that is one of the algorithm. Like we have given the relation R, and we need to directly decompose into 3NF, right? No, sorry, 3NF. Then we need to take the canonical cover. Yeah, you can directly go for that, or otherwise just go for 2NF and check for which are the conditions which are violating 3NF, like we just discussed earlier.
Right.
When we go one level upper, we can just take the violating relation and then decompose it. But if you're doing stepping over multiple NFs, then you might have to do that canonical cover.
Yeah.
Sir, in the mock unit test quiz 2, right? We are discussing.
Yes.
In that, you're saying for the dependency preserving one, right?
Question number 9. Yeah.
Yes, sir. I am in that question. So here the bike name gives bike model and bike model gives bike engine number. So these two are, R1 and R2 will cover these two relations. Bike engine number and bike name is not covered. So you're saying it can still be derived from the other two when you make a union. So it is dependency preserving, right?
Yes.
Okay, got it.
Okay. So any other doubt? Okay, I will quickly go through the revision slide also. Just 1 minute.
So the B3, B+3, 2 node, 4 node, and all that is not there in this exam.
It is in week
That
9.
is in week 9.
Okay, sir.
If you have gone through the mock carefully, then you should be able to score at least 70-80% in the quiz. It's very easy.
So the grading system I wanted to ask for quiz 1 and quiz 2, there were 2 models given. Those still hold good, right? Best of Q1 and Q2 or average of Q1 and Q2.
Okay, so that will decide, yeah.
And for DBMS, what is the pattern for the practical exam, sir? Is it going to be Viva or
online proctored exam is there?
Yeah. So no, that I understood, but will they ask questions like last time? They had a Viva last time, so will there be anything like that?
No, this time we have online proctored exam. In that we'll ask question based on SQL query only, simple select query.
Okay. So the proctors will not ask questions to us, right?
No. Yeah.
Okay, sir.
So on the portal, you will be given the a few questions, and you need to write the query for that. Like simple as we have done in the assignment part, practice and graded SQL.
Got it. And the one with Python is also included, right? The connection.
Yeah. Okay. So probably they like in the portal editor will be there, so you don't need to upload the .sql file. But we'll confirm and we'll send an announcement regarding that. Yeah.
Okay, sir.
You
So
will
it is
also get
better if we get the practice editor a little before the exam, because we might be used to this Postgres model. If it is very similar to that, no problem. But if it's going to look different, or we might need some practice on that.
Like simple editor is there. Like you just need to write the query and do the test run. Click on the test run.
Yeah, errors and all will come in the.
There are syntactical error will come, but like if you wrote the query incorrectly, so it will give an incorrect code along with the output.
No, but if it gives a wrong table, how do we find out, sir? I mean,
we will provide the schema. In every question, a schema will be there, and based on the schema, you need to formulate the query.
No, let's say I made a query and give a wrong result. It's not a syntactical error, but in Python they give the console output, right? So whatever is displayed, I can see if my answer, if it's passing or not. Like that, can we check in DBMS?
No. Like if
it will show incorrect SQL statement.
That's all. Okay.
That's all, and the output you get if you have the correct query. Correct query means it's the syntactically correct.
Okay.
Yes, anyone is asking something. Yes, anyone? Any doubt? Someone was saying. Okay. So in the so week 5 consists of like we discuss about.
We are not seeing the slides if you're trying to.
Yeah. Okay. Like most of the things we have covered in the session, I will just share that slide. So we already shared this 1 week ago, like on Monday. So in this week 5, we have discussed about the functional dependency part, how to find out the candidate key. Okay, let me write it down. Okay, so in this week 5, first we'll see the how to find out the closure of an attribute. So based on that, we can find out the candidate key. Then what are the prime attributes and non-prime attributes? How to find out the extraneous attribute, and canonical cover is there, right? So yeah, closure set, decomposition, canonical cover we discussed, and this lossless join decompose also discussed, right? Example is there, dependency preserving. Yeah, just we're talking about this this algorithm. Decomposition is dependency preserving if F1 union F2 union Fn determines. Okay, so if it's not, then check the correlation of function dependence and require the joint expense, right? You can go through the slide. This one example also, dependency preservation. Now in the week 6, we have gone for the normalization, that is 2NF, 3NF, BCNF and MVD, so that we have also discussed. Okay, anyone has gone through the slide and any doubt in this slide?
Not on the slides, no.
Yeah, okay. So you can follow these steps to connect, like which are the modules for PostgreSQL, PsychoPG2. This is the steps, okay. Then yeah, so there's one SQL injection part also, you can try out that. Like here there is select statement, and here if we mention or with the true thing, it will give us the detail of all the instructor, right? So you can try in the pgadmin or any SQL editor. Then wicket, okay, we have discussed the numerical part, BST also. Go to the slide for theory part. Yes, I am talking about this practice question. So we already discussed that number of leaf node, height of BST, and number of element at level 2. So you can try out this question. You can post your solution on the discourse. Okay. And there is difference between, yeah. So for magnetics numerical, refer practice and graded assignment question. Then yeah, this is the last slide, like organization recording the files. Please go through this content. Okay, we have consolidated all the important points here. So that's it from the summary slide. So please go through it once. Okay, it will be very useful for you. Okay, any other doubt in any of the week? Any question?
No, sir, we are good.
Okay. Okay, then thank you everyone and all the best for quiz.
Thank you, sir.
All the best.
Tomorrow
Thank
at
you.
what time you have the DBMS? Please? Can anyone please? Okay.
It's afternoon, sir, for us.
Afternoon. Okay. Okay. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, everyone, and all the
Thank
best.
you.
Thank you, everyone.
All the
Thank
best.
you, sir.